objective, and let us start from one. So first thing is kinematics. Kinematics is the study of the motion of an object without worrying about why it is moving in a particular way. Kinematics can include graph and calculations that involve time, distance, displacement, speed, velocity, but we don't take into account what? The mass of the object, the forces that may act on the object. For now, we will simplify things further by only considering motion in a straight line. So these are few conditions that he has mentioned. Okay, coming to the next. Now see here. This should be pretty easy for you initially because acceleration comes only into action when you learn distance. Now again here it is y-axis where I am moving my cursor, that is showing distance, and it is x-axis which is showing you time. It shows how the distance of the particle that started at a fixed point changes with time. Why it changes with time? It is changing with time because at 0 second it was here. After 1 second it moved 5 meter. After 2 seconds it moved 10 meter, and likewise. Time is always shown on the horizontal axis. Just remember, horizontal axis means x-axis. The graph is a straight line. This shows that equal distance are covered in equal amount of time. Now see, what is the meaning of this? You can see equal distance in equal amount of time. Why? You have taken 0 to 1, that is 1 second, and distance moved is 5. Again 1 to 2, that is 1 second, and distance moved is 5, from 5 to 10, which is still 5. If you have to count a difference, so 5, 5, 5, 5, and time taken 4 seconds. In other words, it shows that the speed of the object is constant. Do you agree that the speed of the object is constant?
Yes.
Because the object is moving, covering same distance in same amount of time. So speed formula will be distance by time. This corresponds to gradient of the graph, and this is what we mean by gradient. Speed is equal to gradient by distance by time, and speed is also known as gradient. Speed is here 5 meter and 1 second. So 5 meter per second we will say as the speed. We write meter per second as ms. I asked you earlier, m obliquates, what is that? So here it is mentioned meter per second, not miles per second. Or sometimes like this. So I am pretty hopeful. This part there is no doubt till now. Is there any doubt so far?
No.
Okay. Moving to the next. Sarah set off from home to work. Okay. She walks 80 meters in 90 seconds. Then she stops to answer her mobile phone. After 30 seconds, she walks home at twice her initial speed. Draw the distance time graph of Sarah's journey. To draw the graph, the vertical axis must go up to 80 meter because distance is shown vertically, and here she goes up to 80 meter. So it is up to 80 meter, you can see. Sarah returns at twice her initial speed, so it takes only half as long. Okay.
Okay.
Her total journey time in seconds is 90 seconds, because initially she goes for 90 seconds, then 30 is what? After 30 seconds she walks home at, okay, she stops to answer mobile call for 30 seconds, and then she moves at double the speed and comes back. We show this on horizontal axis. So see here, horizontal axis is this, time is shown here. The 3 stages of journey may now be shown as a graph. Here is her first walk. Now see, she goes at a speed of, no, speed is not here. She first moves up to 80 meter in 90 seconds. Till here it is 80 meter and 90 seconds. After that she stops. The graph has zero gradient, showing that the speed is 0. Now see here, from here to here her speed is 0. Why? Because at the beginning 90 seconds she stopped here, until 120 second the distance moved is not anything more than 80. It is just 80 here also. So from 90 to 120 distance moved is only 80 meter. That means no distance is moved. That means she is stopped at that point. She is standing and answering any phone call and not moving. So that is shown by horizontal line. And next, the second stage of graph has zero gradient, showing that okay, the gradient for the final stage is negative. From here she will start coming back. So see here, now she has come back to her place in half the time, that is 45 seconds, and total time taken in the journey is, so return speed will be what, 80 meter, and 80 meter covered in 45 seconds, 16 by 9, that is 1.78 meter per second. Now this so this part is over, and then what next? Oh, then they have questions. Let me. So before I proceed, I just need to discuss a few things. This is the graph of Sarah's journey, and just remember, first she goes up to 80 meter, so that is shown here. She goes up to 80 meter, so that is shown by this line, and then she stops for 30 seconds. From 90 to 120 will be 30 seconds. So here to here she is not moving, so it is a horizontal line, and then she comes back at double speed, so time taken will be half. Initially she took 90 seconds, so now she will take only 45 seconds, and she will come back. So she came back. Now if you calculate, it is 120, and it is 120 to this is 165 here. Between 150 and 180, it is 165. So 120 to 165 will give you 45 seconds. She has taken 45 seconds to come back. Now tell me, have you understood this graph? Then only rest of the question you can do.
Pardon?
Have you understood this graph?
Yes.
How she moves, where she stops, for how many, and how we can represent it on graph. Everything is clear?
Yeah.
Okay. So then I will move now to question part where you will have to answer the questions. And if you have any doubt, I will explain. Is that okay?
Yes, please.